Hi everyone, my name is Baastian Olij, and I've joined forces with Nathan to bring you part 2 of this tutorial. I will show you how to do similar shaders but in 3D. Now, don't go skipping Nathan's video if you are only interested in 3D. He will explain basics, so I won't be covering those, and seeing things first in 2D helps to understand them better. So I hope you enjoyed this video. Please join me afterwards on my channel for part 2. The link will be in the description below.
So in this tutorial, or this tutorial series, we're going to see how to recreate this water shader that's not too advanced yet, but you can see there's a lot of detail and motion inside of it, and it's all handled by the computer using shaders, programs that run on your graphics card and that manipulate every pixel inside of the water sprite. So we're going to start with a first shader that will animate the Godot bot, just to get started and talk about the difference between vertex and fragment shaders. Then we're going to go straight to the water and animate the pixels using a fragment shader and a periodic mathematical function. The next step is to use a texture to deform our water instead of using mathematical functions, because with math you can only do so much, while with a texture you can control precisely how the deformation looks, and you can see you can create a much noisier effect, much more profound. Then we will add some lighting to it, just to see that you can combine your shaders with the Light 2D node and use what's called a normal map. We will combine the two waves approach into one shader, so this is the water sign plus the water texture offset. And finally we'll add some shadows and manipulate the normal map to interact with the light from the shader to animate it as well, to create that slightly more convincing water effect. Let's start with a basic vertex shader. I invite you to grab the demo where you'll find the first shader and water folders on GitHub, link in the description. In the water folder, you'll find some textures and a base scene to create our water shaders. And in the first shader folder, that's what we're going to start with, you'll find the Godot bot and a little bit of interface we'll use to see how we can manipulate values in the shader from GDscript to animate your materials, do transitions, and things like these. But first, let's start by creating our base shader. For that, we're going to open the Dancing Godot scene. You can find it in First Shader, Dancing Godot. Double click to open it. And this one only contains a UI node, a texture rectangle, and we're going to add a shader to it. In the node tree, every element that inherits from canvas item can take a 2D shader. This is true for all control nodes, so UI nodes, and all node 2Ds, all sprites, animated sprites, etc. So we're going to head down in the inspector to the canvas item section. This is where you'll find the material slot, where you can add a material to your object. So you first need to add a material, and you're going to add the shader, the code that controls your image and its vertices inside the material. So click on the arrow next to the material on the slot and create a new shader material. We're going to enter it now, and you can see it has an empty shader slot, so we're going to create a new shader for that. And when you click on the shader, a shader code editor will appear, and we get an error because we need to define some base code for the shader to run. But before we start coding, we're going to save those shaders as resources inside our project. Click the back arrow to head back to the shader material, and you can click the save button. This allows you to save any file, any resource as a reusable component inside of your project file system, instead of having the code saved or burned inside the scene. So let's go to first shader, Dancing Godot, and you can call it Dancing Godot material, for example. Save it, and we're going to do the same for the shader. So we enter back in the shader by clicking on it, click the save button, save as, and it's going to be Dancing Godot. And as the extension is already .shader, I'll just name it this way. Alright, to start with, we have to define the shader's type. For that, this is the first line at the top of the shader, and you write shader underscore type. And for 2D items, it's always going to be canvas item, and you have to end the statement with a semicolon. Any shader in the 2D workspace is going to start with this line. Then we can start to manipulate our sprite. Godot's shading language is very close to GLSL, and it looks a little bit like C. So we'll have to add semicolons at the end end of statements, but we're also going to write typed code, meaning every function or variable that we write has an assigned type and you cannot use it in a different context. It will not convert automatically. But first, let's talk about the built-in functions. We have two that we're most interested in right now. The first one is Vertex. We're going to use that function to manipulate the vertices of our object on the GPU. So the vertices on a 2D object are the four corners of its bounding box. But in the upcoming version 3.1, you'll be able to create a mesh in the 2D workspace as well, and to manipulate the mesh, like each of the points, using this vertex function. So the code in your vertex function will run once per vertex on your object, and then the fragment shader will run once per pixel. There are many more pixels than vertices in a typical game. You can do some optimizations, you can improve the performances sometimes by using the vertex shader. For example, vertices have colors that you can then reuse inside of the fragment shader, but this is a more advanced topic. For now, we're just going to manipulate the vertices of our dancing Godot to make it dance a little bit. For that, we have a property called vertex that is an output from the vertex function. It starts with the coordinates of each vertex, and if we manipulate its value, it's going to move the vertices on the dancing Godot. So let's type vertex, it's in all caps, and we could write equal vertex plus, we're going to add a vector2, so you use the vec2 constructor to define it, and we're going to define it as an offset of 1.0 on each axis, 1 unit, and finally we're going to add a semicolon at the end of every line. And you can see it moves our vertices by 1 unit. In 2D, this is 1 pixel. You can use a larger value on the x-axis, for example, to offset the Godot on the x-axis a little more. Now, for 1, we can write plus equal instead of equal to add something to the vertex. You can also use minus equal to subtract to the vertex position. Okay, so that's fine. And we can also animate it. So we could use time multiplied by a value, and this is going to move the object 1 pixels per second over time. But the problem is it's moving outside of the object's bounding box because time is the value, the time value since Godot started, so it can become very high. That's why we make sure that we use a periodic function like a cosine to loop the animation of the object instead of offsetting it over time like to infinity. We're going to increase the size of our vector here, and you're going to see our object move in diagonal in this case. So if you want to move an object or a texture or anything in diagonal, you can use cosine or sine to move in one of the two main diagonals. Then if you want to make it move in circle, use a cosine on the x-axis. Then if you want to move the object separately on the x and y-axis to make it move in a circle, you can do that by using a cosine on the x-axis and a sine on the y-axis. Now we can access the x-axis of our vertex, the x-coordinate, by adding a dot and then using the x value. So you can slice a vector using x, y, z for the coordinates, and you can also call these RGB for colors, but this is kind of syntactic sugar. RGB and x, y, z access the same thing, the x, y, and z components of the vector. So the problem now is we are assigning or trying to assign a vector2 value to what's now only a floating point value because it's only the x-axis of the vertex. So let's remove that vector2 and only multiply the cosine by a floating point value. Now we're going to duplicate the line. Works just like the Godot script editor, Control B, and we'll replace the cosine with a sine, and we're going to manipulate the y value of the vertex property. We are offsetting the vertex position of our Godot bot over time using a periodic function, so it's cyclic. It's always going to move in circles in the same way. We can randomize the effect per vertex by adding the vertex coordinates inside of our periodic function. So you could add vertex.x to the x component and vertex.y to the y component to offset the effect of the periodic function per vertex. You can see the motion changes quite a bit. You can also try different combinations, like adding the vertex X and Y per vertices to make sure that you get a different value on every axis. So you add both X and Y for the cosine on the X component, and you add the vertex X and Y on the cosine for the Y component. This is a cheap way to randomize a value per vertex, and we'll see that we can do that per pixel as well in the fragment shader. But there you go, we have our dancing Godot. Let me comment out the 2 lines of code to stop the animation for now, and we're going to see another essential part of shader programming, adding properties that you can manipulate outside the shader from GDscript, for example, to control the speed, the look, whatever you want inside of the shader. It's a little bit like exported properties in GDscript, except for shaders, these are called uniforms. So outside your vertex function, you can declare uniform variables. So you start with the uniform keyword. It kind of means exported. It also means that the value is going to be available in all functions in the shader, so in the vertex and later the fragment or the light shader. Then you're going to write the type of the value. So let's start with a floating value that we'll call time factor to control the speed of our animation. You can give it a default value and don't forget the semicolon at the end of the line. So the time factor we're going to use inside of the periodic functions to multiply the time value to make the animation faster or slower. Then we want to replace that static 20 pixels offset by an amplitude value, for example. So we're going to create another uniform. This time it's going to be a vector2 value, and we'll call it amplitude to control the amplitude of the motion separately on the X and Y axes. We can give it a default value of 10 and 5.0, for example, to make sure that we see that we have different values on the X and Y axes. I'm going to uncomment the 2 lines here, and we can multiply the time by time factor. So as it is 1 for now, it's not going to do anything. We can change the default value here by 0.2, for example, to slow down the animation instantly. And then we're going to replace the amplitude value at the end with amplitude.x for the x component of our vertex shader and amplitude.y for the y component to get a much larger effect on the x-axis than on the y-axis. For the time factor, let's use something a little higher to see the motion go faster. Alright, so now we've changed the values inside the shader, but we can change them outside the shader, and that is what your material is all about. As we save the material inside the file system, you can double click it to open it inside the inspector. And there's a category called shader param. Click it to unfold it, and you will find the 2 values we created, time factor and amplitude. So right now they are not defined, meaning the shader will use the default values we defined in it. But if you set the time factor to 3, it updates instantly. That's also an advantage over modifying the values inside the shader because it updates much faster. We can set the amplitude to a much higher value to see Godot jiggle like crazy and modify them anytime. And the thing is, you can then save these values when you save the scene or you save the material, get encoded inside this resource. You can also create variations of a shader by modifying these parameters and saving your resource as to have the same shader with different color variations, etc. So this helps to make shaders more reusable in your game projects. So we have those exported values, those uniforms, and now they are properties of a material, so we can control them from GDscript. That's the next step. So let's go back up to the first shader folder. You'll find an interface subfolder with an amplitude controller. This little widget has a slider, and that's in a container where you can move the slider, and we're going to make it so the X amplitude text updates to show the X amplitude value. The slider in Godot, it's a base UI component that's clickable. You can click and drag to edit the slider's value. Right now, in the range value of the slider, it has a value between 1 and 20, and it goes in 1 pixel increments or in increments of 1. And the start value is 15. You can change the value to see the slider update. Now we're going to funnel the value from the slider to the amplitude controller, which is the entire widget, and it has to store the amplitude value, etc. And it will send it back down to the label to update it. So first we need a script on the amplitude controller. So select the node, add a new script. We're going to add it to the interface folder and call it amplitude controller. I tend to use lowercase for scripts as they are slaves or extend the node and scene. Let's create this, and we're going to remove almost everything. We want to connect the slider's value change signal to the amplitude controller. Select the slider, head to the node tab, double click value changed, and double click amplitude controller. When the slider's value changes, we're going to update an amplitude value. Let's create a new amplitude variable to store that. It's going to be a floating point values. Let's start with a 10.0, for example, and we're going to use a setter to update it. So we're going to use a function. For that, you write setGet followed by the method name. The convention is to use set amplitude. So we only define a setter function, a function called set amplitude that's going to be called every time we write something like self.amplitude is equal to, in this case, the new value on the slider. Now we have to define this function as well. Let's create set amplitude. The setters always get a parameter called value. You have to use it. We have to assign the value to the variable. Otherwise, the amplitude variable will not change. And then we're going to use that setter to do a few other things. So we're going to set the text on the label when we change the amplitude value. And it's going to be label start text plus a space plus we're going to add amplitude converted to a string using the str function. Convert a floating point or an integer value to a string. And we have to define the label start text here. So let's add a new variable. It's going to be on ready because we need to access the text from the label. We're going to grab the label and store the text at the start of the game. And finally, we're going to emit a signal every time we change the amplitude because we make a change on the interface and we want to receive that change. We want to put it inside our shader, inside our dancing Godot, but we don't want to do this directly from this script as it would couple the interface and the sprite. To do this a little more cleanly, we use signals and we're going to call it amplitude changed, and it's going to take the amplitude value. And finally, we can emit the signal when we change the amplitude in the set amplitude function. We're going to call amplitude changed, and we're going to emit the value, in this case, or the amplitude variable. Note that to use the setter function from within this script, you have to use the explicit self.amplitude, meaning I want to change the amplitude value on this instance, and only if you do it explicitly like that will it call the setter function. Otherwise, you will just, if you write this, just amplitude equals value, it's going to ignore your set amplitude function. So make sure that you have self before it. Okay, that's it for the interface. So now every time we update the slider, it's going to update the amplitude container. We can see that in the editor by adding the tool keyword at the top of the amplitude controller script, save. Now we've got to add a script to the slider with the tool keyword as well for it to update. So we're going to add it to the interface folder, create a script called slider.gd. It's going to be empty. It will just have the tool keyword at the start and it has to extend the slider class. Okay, so let's close, reopen the amplitude controller, and we're going to change the value. You'll see the label updates as well. Now we have our interface set up. I will close both scenes, go back one folder up to the first shader scene where you have both the dancing Godot and the interface bit. So we're now going to see how to get parameters from the shader and also how to modify them based on the interface, but just in general how to update them from GDscript. So select the dancing Godot. We're going to give it a new script. And I'll use the snake case for that as usual. So dancing Godot, create the script, remove almost everything, and we'll start by getting the value from the shader. So for that, let me create a new variable. I'll call it amplitude, set it to grab the value when the scene is ready. If I go to the inspector and go down to our material in the canvas item category, you'll see that there's a property called material that holds this. And so we can access that directly. So we'll call our material, and it has a method called get_shader_param. Lets you grab a shader parameter, get a value from it, and we can get our amplitude. So you have to pass in the name from the parameter. If I enter the material and hover the amplitude, it will be amplitude, as you can see, shader param / amplitude. Note that as this is a property like any other in the inspector, you can also use the get method directly to get the value. So when you do that, you use the path to the property. You could use material.get or simply get, and then enter the path to the string property, in which case it would be material / shader param maybe / amplitude. That's another way to write it. It's a bit like getting a node in Godot. Properties can be accessed in the same way. All right, so now we get our amplitude. We're going to print it and just do some checks on it. So let's add the ready function that will be run after everything that has the onReady keyword. And in the ready function, we will print our amplitude. Now in this example, I've already set it to 5, 5, but by default, the amplitude or any parameter in the shader can be null. And if the value is null, you may have some problems when you start to use it. So one thing you can write is use an assert statement to make sure that a condition is met. So you can make sure that amplitude is not null, okay? And if the amplitude is null, if you haven't set the value in your shader, this will trigger an error in the console when you run the game. But for now, let's just print and press F6 to play the current scene. You should see the value 5, 5 print in the console. Okay, so we are getting our amplitude. Now we want to update it when we move the slider in the scene. For that, select the amplitude controller, the interface bit, go to the node tab, and we define our amplitude change signal. So we're going to connect it to the dancing Godot. It's going to create a new onAmplitude controller, amplitude changed. Click connect to create it, access the script. And now we're going to get a new amplitude that I'll call amplitude X, because we are only getting a value on the X axis. The slider has only one value, right? So it's a floating point or an integer value. And now we can use that to update our amplitude variable. So we're going to set the amplitude's X component to our new amplitude X. Or we could call the parameter value as well, by the way. You can call it however you'd like. All that matters is that you have the right number of parameters when you get a callback from a signal. So we set the amplitude X component to that value, and then we're going to get our material again and set the shader parameter this time. We need the name of the parameter, amplitude, and then assign it a new value. We'll use our new amplitude vector2. And I'll also copy the print statement so that you can see in the console that this function gets called when we move the slider. I'll press F6 to play the game again. And here, if you click and slide the slider, you will see the shader animation gets bigger or smaller, and in the console you can see the new amplitude value printed on every tick. So this is very important when you want to animate your shaders or make them react to things that are happening in the game. Increase a color, the intensity of a shader, motion. If you use a shader to move grass and trees in your game, for example, you may have a global wind value that you modify based on your weather system, and that then takes control of the grass's animation and all that.